Now, for those of you who are also doing extension 1, we did do this in year 11, where we did relation rates, but it was also what was done when you went on the French trip, so probably a good idea to see it again, a good little bit of review. So what we are doing, a lot of these questions are on the practical side. We want to use what is called the chain rule to help us to differentiate something. So a chain rule, there is an example here. If I'm trying to find the rate of change of the volume, now when I'm talking about the volume of a question, so there's one down here talking about a sphere. If I want to know the rate of change of that volume of the sphere, I'm talking about over time, because as time progresses, I want to know what is happening. So I want a dV over dt. However, the equation that I have for volume doesn't involve time. Okay, so I need to do this lovely little manipulation here to try and get the derivative into the units that I want. The volume of a sphere, for example, usually has radius in it. So I can differentiate the volume with respect to the radius. And then usually in the question, they might give you some other information to get something like this one, the dr over dt. Now what happens, this is algebra, this dr and this dr can cancel out of those two derivatives, and that's why it's equal to dv over dt. Okay, so that kind of thing, it won't always be in terms of V's and T's and R's. The letters in the chain rule will change, but you will be doing this kind of things where you're trying to work out what derivatives do I have, how can I put them together to cancel them into the units that I want. Okay, all right, so best just to go to the questions, I think, so you can see more of what I'm talking about. So the first question says the radius of a sphere is increasing at 0.3 centimeters per second. If the radius is 10 centimeters, find the rate of increase in terms of pi of the surface area. Okay, if I want the rate of change of the surface area, this is saying that I want to know how the surface area is changing over time. That's what it's asking me to find. However, what is this number in here that I have in the question? It says 3 centimeters per second. Let's read back here. The radius of a sphere is changing at 0.3 centimeters per second. Radius. This is a radius, and this second stands for time. So that number would represent dr over dt, because it's how the radius is changing over time. Okay, the other thing that is important here is the shape. It is a sphere, and unfortunately not too many of your measurement formulas are on your formula sheet, so you need to know what is the formula for the surface area, think back to year 10, of a sphere. S4. Oh, I'm hearing whispers of all sorts of things. 3/4 was the volume. 3/4 pi r cubed is volume. What is surface area? Oh, no one knows. Oh dear. We might need to give you some lists of formulas. All right, it's 4 pi r squared. Okay, that is the formula for the surface area of a sphere. Now, I can differentiate that. I'm differentiating the x with respect to what letter am I going to be differentiating on this side? R. So it's a ds over a dr. Okay. When I differentiate, the 2 comes down. 4 times 2 is 8 pi and r. Okay. I have all the bits that I need. Now let's do a chain rule. So what I want, remember, is ds over dt. That's what I'm trying to get. Okay, I have an equation over here that's a ds over dr. Okay, that's a good place to start. That would be a ds over a dr. And if I multiply that by my dr over dt, this one over here, that would work because, again, the dRs would cancel out, and there's my ds over dt that I want. Okay, see how I've set up that chain rule? Okay, now we can sub in the things that we found. ds over dr was 8 pi r. dr over dt was 0.3. Okay, so don't really like decimals, but we're stuck with it. It's 2.4 pi r. Okay, there is one more little part that we haven't dealt with yet. We've found the rate of increase, but now it wants it to know specifically when the radius was equal to 10. That is like a general expression for the rate of change of the surface area over time. But if I want to specifically when x is equal to, not x, sorry, r, radius is equal to 10, I'm going to sub that in for the last part. So I'm just going to say when r equals 10, the ds over dt is going to be 2.4 pi times by 10, and we get an answer. If I leave it exact, that's 24 pi, because 2.4 times 10 is 24 pi. Now, we should include units in our answer, and we can work out the units from our derivative over here. The thing on top is the surface area. What is the units of surface area? Yes, so this will be centimetres squared per. On the bottom we have time, and my units for time are seconds. So there it is, there's my answer. Please do not ever sub in this thing, the r equals 10. Don't sub it in early. You have to work out with your chain rule first, work out your expression, and only sub in at the very end. If you try to sub in early, it will completely mess everything up, okay? Now we're going to do it again, but this time instead of surface area, we want to do volume. We want the rate of change of volume, which means we're after a dv over dt. That's what we want. Luckily for you, we already mentioned the formula for volume of a sphere. 4 over 3 pi r cubed. Okay, to differentiate, I'm going to go differentiating v with respect to r. So no shorthand notations for derivatives because you need to know the units that you're comparing, okay? This 3 is going to times down the front. So the 4 over 3 times 3 is just going to make 4 pi r squared. Hey, that's pretty cool, isn't it? Did you know that differentiating volume, you get surface area? Cool fact. Anyway, on to the next part. I am trying to find, this is the chain rule, I am trying to find dv over dt. So I always like to start with the v. I know I need the v on top, which means this one here, this dv over dr, I'm going to start with that one. dv over dr times by, okay, I need to get rid of the r out of my answer. And if we go back to our question, remember we had this dr over dt. We can still use it. Still applies. So I'm going to times by dr over dt. How are we going with the chain rule part? Is that okay? How I'm setting those up? Makes sense? Okay, sub in then. dv over dr is 4 pi r squared. dr over dt is 0.3. So that equals, what's that, 1.2? 1.2 pi r squared. Yeah? Yeah. Okay, then, like last time, I want to substitute in that r is equal to 10. We save that for the end. So dv over dt, the rate of change of the volume over time, will be 4 pi r, subbing in the r is 10, 4 pi times 10 squared. Oh, sorry, start again. Should be doing 1.2. I subbed into the wrong one. 1.2 pi times 10 squared. 10 squared is 100. 100 times 1.2 will be 120 pi. Units. Volume is on top. Yes, it will be centimetres cubed per second. Rate of change of volume over time. Yeah, not too bad? Okay, question 2. Let's try another one. A balloon is being filled with air at a rate of 150 centimetres cubed per second. Now, it doesn't really emphasise it too much what that represents, but the units to help. It's a centimetre cubed per second. Centimetres cubed has got to be a volume. That is the volume changing over time. Okay. Assuming that the balloon remains spherical, which would never happen, but anyway, we're having a perfect sphere here because we have to have a formula that we can use. At what rate is the radius changing? What am I after? The radius changing over time. Good. And then it does say at the end when the radius is 3 centimetres, but we'll save that 3 centimetres for the very end once we've got our derivative that we want. Okay, then we sub in at the end. Okay, so first of all, what formula can I start with? It's the shape. What shape am I talking about? A sphere again. So it is volume. The volume of a sphere is 4 over 3 pi r cubed. Just like last time, we differentiate. The volume with respect to radius becomes 4 pi r squared. Okay, this one we need to be a bit sneaky. In my question, I'm asked to find the radius with respect to time. Okay? Do I have either of my things? Yes, I do. That has a radius on top. That's the one that I want. What about these other ones? Do these other ones here have a radius on top? No. Okay. This one has the dr that I want, but it's upside down. Okay? I can flip it. If I want a dr over a dv, if I invert this side, guess what I do to that side? Invert it as well. So it will be 1 over 4 pi r squared. Okay, that's better because now I have a dr on top. So I can put dr over dv and then times that by, I know the dv has to cancel out. Here it is, there's my dv on the top. So it's going to be a dv over dt. dv on the top, dv on the bottom, they will cancel. And there's my dr over dt. Okay, so let's sub in. dr over dv is 1 over 4 pi r squared times by dv over dt, which is 150. Okay, 150 divided by 4. If I keep it exact, I can divide top and bottom by 2. It'll be 75 over 2 pi r squared. Okay, so there's my expression for dr over dt, or my equation, I should say, for dr over dt. But now I want to sub in that bit of information that I was leaving to the end, which was that the radius is equal to 3. So when r equals 3, we will get dr over dt equal to 75 over 2 pi times 3 squared, and exact, when you type that in, you get 25 over 6 pi. No, why are you looking like that? You didn't like, oh, you didn't do it. Okay, so if your calculator gave you the decimal, type everything in without the pi symbol. So just type in 75 over 2 times 3 squared, and it will give you, hopefully it will give you the 25 over 6. Yeah, it means put the pi back in. Okay, units. This is volume over time. My volume was in centimetres again. No, sorry, it's radius over time. Radius over time. My radius is centimetres per second. Not squared, not cubed, so it's not volume or surface area. It's just a radius over time. Okay, let's try a different shape. A cone. A conical tank. Don't you like that word? It just means a cone. A tank in the shape of a cone, full of water, loses water at a rate of 1.2 meters cubed per minute. What is that number? It's a volume changing over time. So it's a dV over a dt. All right, keep reading. When a tap at the bottom is turned on, if the surface area of the water of the tank is always equal to 2/3 of the depth of the water, then find the rate at which the depth of the water is changing when the depth is 2 meters. All right, let's try reading this part again. If the surface area of the water, surface radius of the water is always equal to 2/3 of the depth of the water. Can you make that into a little equation for me? So the surface radius just means radius. What does my radius equal? 2/3 of the height. Always, apparently. Okay, so that's one of my starting equations. I'm asked to find the rate at which the depth of the water is changing, which would be over time. What's that as a derivative? Yes. So this thing here that I'm asked to find, I'm trying to find a dH over a dt eventually. Okay, I've got an equation over here that's got R and H in it. I've got something here that has volume and time in it. Obviously, if this has a volume, I'm probably going to need a volume formula as well. Okay, so volume of a cone, what is it? V equals one. Did you say a fourth? Okay, no. Oh dear, we really need to. Okay, yeah, that's a good start. That is the formula. It's not finished. That is the formula for a cylinder. What fraction of a cylinder is a cone? A third. Thank you. It is a third pi r squared h. All right, differentiating. Actually, before I differentiate, I can't differentiate yet because I have a problem. I have R's and H's in here. That's a bit of a problem. But, happy days, look up here. I have an equation that has R and H in it. So let's sub R, which is equal to 2/3 H, into that equation for the volume. So it's a third pi. R is going to get replaced with 2/3 H. That has to be squared times another H. All right, so this is my R squared. I've got to tidy that up. So 2/3 squared is 4/9. Times an extra third out the front would be 4/27. I have a pi on the top. I have a h squared here times another h there. So it becomes a h cubed. Okay, that is much better because now I have an equation that just has two variables in it, volume and height. So I can differentiate the volume with respect to the height. What do I get? The 3 will times down the front. So 3 times 4/27 would be 12/27, but that simplifies, doesn't it? 4/9. And then it would be pi h squared, because you subtract 1 from the power. Okay, we are ready to do a chain rule. In red, I wrote down that I am asked in this question to find dH over dt. That means I'm going to need a dH over something to start with. What do I have? A dH over, do I have anything? This one. I could turn that upside down, couldn't I? So let's make it a dH over dV, and I'll know that I'm going to turn that one upside down. And then I would need to get the V to cancel off, so I need a dV over, dt. dV over dt, we have that. Okay, let's 4 pi h squared. Flip it. Thank you. Times that by the dv over dt, which was 1.2. And that would equal something. Anyone want to type that in for me? Because I don't know what that is. What's 1.2 times 9 over 4? 27 over what? 10, thank you. Pi h squared. Okay, finally, we had one little part left. This 2 meters. We want this rate of change when the height is equal to 2, because that's a depth, which means the height, h, is 2. So we sub in when h equals 2, and we get dh over dt equals 27 over 10 pi times 2 squared, and then get an answer. 27 over 40? 40 pi. Yeah. So I've left all of my answers exact because I didn't say decimal places. So I've just left them exact. What are the units of that? Meters per minute. Because time was in minutes this time. All right. So there's only a few questions there, but yes, they do take a bit of fiddling. Let's do 9E.